refresh. First, all the awakes get called, like we want. Then all the starts get called. Now, of course, this means if I click on one of these, oh, I think my click must be wrong. Welcome back to Arcade. I am Super Tommy, and in this video, we're going to take a look at creating a component system to use in Phaser 3.50. Now, if you've used Phaser Editor 2D, they have a component system as well. Ours is going to be a little bit different, but conceptually it's going to be the same. It's also similar to Unity components. So this is not ECS, it's not Entity Component System, but just the component pattern used here without the more complex Entity Component System. So the component pattern is being able to separate your logic for each entity, for each game object, let's just say, so we don't confuse terms. So for, let's say, in our example here, we've got these jellies, and each one, let's say they can do something different. Let's say the green ones and do something different than the yellow ones. Let's just say the green ones explode a certain way, and the yellow ones only explode up and down. Let's go with that. Classic match 3. Let's say when these yellow ones match, they only explode up vertically. Yep. And let's say the green ones will explode horizontally. And then let's just say this red one explodes in the nearest cells directly adjacent to it. Right? So a lot of things they'll share, right? These jellies will share very similar things. They have the same swipe gesture, let's say. That if you do click and then drag, it'll swap with the neighboring cell. So they have some things that are different, some things that are similar. Now, one way to approach it is by inheritance, but you can see that's going to be already complicated. If they share some things but not other things, and then you have like this tree where you've got this base object and it's like red, yellow, green inherits from this base object, and then because they do something different now, something else inherits from this other thing, and this here, and then then you realize, well, maybe at the end later, some other children here need to do the same thing as a couple of parents somewhere else up the tree, and you have this big mess. And every time you update something in the base class, it may break something in the child classes. So I believe the component pattern was first, at least popularized by Vicarious Visions in Tony Hawk Pro Skater, the original Tony Hawk Pro Skater game for PlayStation. I could be wrong. That's what I remember. Let me know in the comments if I'm actually incorrect. And while you're there, be sure to hit like and subscribe to the Arcade YouTube channel for more videos on making games for the web. So this component pattern is very popular. It's used in Unity. If you've done Unity development, you've definitely used it with the model behaviors. So we're going to model this very similarly, but we're building it on top of Phaser. And we're going to do it in a way that doesn't modify the Phaser game objects at all. We're just going to have a component service that works alongside Phaser. Now, there may be optimizations you can do if you built it, or you kind of like in JavaScript here, injected it into Phaser. That's definitely a possibility, depending on what you need. But in our example here, we're going to create a separate service that lives outside of Phaser and simply works with Phaser game objects. Okay. Now, if you do want to look at making games with Phaser Editor's component system, we do have a playlist here. Our memory match in Phaser Editor 2D. Go to the Arcade YouTube channel. That's youtube.com/arcadehq. You can check out this playlist. Phaser Editor is great for other things as well than just the component system. They've got prefabs and an actual editor for you to lay out your world. So go check that out if you're interested in that. Our approach is going to be entirely code. Our approach in this video is going to be entirely code. We're going to do here, we've got this demo just to set some things up, so that we're going to basically, let's make myself smaller, show you how to set up a component pattern for your game. Then we're going to use it very simply to attach components to our jellies. We're going to probably do something simple like click on it and it'll have a message, right? That's the first thing. And then you can attach multiple components to your jellies and just use logic as you see fit. And so we're going to just do a very simple click component just to show you how it's done. Now, most of this video is going to be It's going to go over creating our component service so that you can then use it generically in all your games. So that's would be the cool part of this video. This is a preamble, I suppose, or a prerequisite for our next video, which we're going to actually do how to detect a swipe gesture in Phaser. So be sure to subscribe and come back for that video if you're interested in that. So right now we're going to do our component service. So this is our scene. This is just using our often used Phaser 3 parcel template at the arcade GitHub. That's github.com/arcade. And we have some to-dos here just to set out the scene. We did not even rename the scene because this is just for showcase how this works. So we're gonna need to make a component service, and then we're gonna add components to each jelly. We got 9 here, and then we're going to update our components in the update tick, since our component will have a bunch of lifecycle hooks, let's say. So let's go to our component service here. We already have a skeleton of this. So let's just go over this quickly, or maybe not quickly, but I'm going to describe to you what our component service is going to need to do and what our components are going to have. So first, let's just go top down. This is just a type for constructor. So we're sort of mimicking Unity system. We definitely don't need to do it this way. But I like Unity system. I think it's good. So we're just mimicking. It may not be the best for TypeScript necessarily or JavaScript, but I just do it this way for now. So what this does is a constructor type in TypeScript, and we're going to use that when we do find component, right? When we want to do a find component, we're going to find it by the constructor type. Now, of course, you could do it by string or ID or something, but in Unity, they do it by the type or the class type. So we're going to just follow that. We're going to use that as inspiration for this one. That's what this constructor type is. Now, then we have an interface for each component. So our component service here is going to have all our components for each game object that we add a component to. And each component is going to adhere to this interface. So you need an init. So in init, we're going to give you the game object so that you can use it inside that component. You're going to need it if you want to like move your game object around, or change colors, hint, whatever it might be you want to interact with that game object. And then optionally, there's the awake start update, which gets an update tick every game update, and then destroy to clean up. Now these are optional because if you don't specify an awake, you just won't call it, much in the same way that Unity does it. So this is the interface of all our components. Let's go down here to our component service class. So this is the class that's going to handle all of the logic. So what we need to do is, given a game object, we want to add a component to it. We're going to do add component, passes this game object, and then give us a instance of a component that adheres to the iComponent interface that we talked about right here. Now the to-dos that we have is we're going to put our game object in a map. Now to map it, we're going to give each game object a unique ID. Now we're going to do that by setting the game object's name property. So we'll go over why we can do that a little bit later. Next thing, we're going to make sure, because the components are a list of components for each game object, right? So let's say this green jelly can have 0 to basically infinite number of components added to it. So that'll be in a list, which is this iComponent list here. So this is the map that we're using. We're going to store each list of components by the game object based on the game object's unique ID. And so we're going to just do that check here. And then we're going to start calling each of the lifecycle hooks. And this is one of the key parts of our components, is that awake is called immediately. Well, init is called immediately. And then awake is called if you've defined it. Now, after all the awakes have been called, so when you add each component when your game starts, awake is called on every single component that you've added at the time on that frame. And then on the next update, start is called after all the awakes are called. This is how it works in Phaser Editor as well. What we're going to do is queue all our components that have a start method, right? This is optional. So if it is defined, then we're going to add it to a queue for start queue. And then in our first update, we're going to process all of those queued for start components. And then after that, we're going to update each component to give it an update tick. Now, doing it this way also means that during runtime, you can add a component, right? It'll call init, it'll call awake, and then later, if you add 3 components in a row, let's say on one tick during runtime, you'll still get the same order functionality where all the awakes get called, and then later all the starts get called. So if you have some code that you need to happen before any starts get called, that's what you would use this for, just in the same way that Unity has it. All right, so that is the description of what we're going to do. Now let's actually do it. So we're using short ID. Let's briefly mention this when we do the ID for each game object. Now, why can we give a unique name to each game object, and why should we do that instead? So in our map, we're just going to key it by string. And by doing that, let's go to Phaser game object here. Now this is the game object documentation in Phaser for game object. This is the name property. Now Phaser says here that the name of this game object is what the name is, which is obvious, is empty by default and never populated by Phaser. This is meant to be used by you, the developer. As it says here, Phaser, this is left for developers to use. Oh, sorry, this is left for developers to use. So now we're going to use this. Since Phaser doesn't actually do anything with this, it is put there for us to use. Now there's no ID on here, right? We look for ID. And there's there's no actual ID property. So we're going to use the name property to give it a unique ID. So now we're using short UUID. UUIDs are just unique identifiers. We're going to use short UUID just because it's shorter. You could use a normal UUID. Or just, you can even use incrementing integers theoretically, but I prefer to use UUIDs than incrementing integers. So first thing here, if our game object comes in and does not have a value in name. So we're assuming if there's a value in name that it's an ID that's already been set. So if GameObject.name, if not, we're going to set it. So go.name is going to be short.generate. So now we give our game object a unique ID if it does not have one. And then we want to make sure that our map has an entry for this game object if it does not exist. So if this component by game object has go.name. So now if it's not has, which means this is the first time we've seen this game object, we don't have an entry for it in our lookup map here, we are going to set by go.name an empty list. Now we are doing this so that when we, in the next part here, so that when we want to add a game object to this list, we can just do list this.components by GameObject.get go.name. Now we can be certain that at this point we do have a list. So this is not going to be undefined, even though it says it is, because the map, when you do get, the return value is whatever it is or possibly undefined. In our case, we know that it's not undefined because we checked up here that if it does not have it, we add an empty list. So we can be sure when we get to the next part here, that list is not null. So first, then we do list.push, the component that we want to add. Right, awesome. Next is our lifecycle hook. So we do component.init. That's the first thing. We want to call init first and pass in the game object to our component so that we can use it. Then if component.await. Since awake is optional, it may not be defined. So if it is defined, .awake, we're going to call it. And next thing, we need to queue them for start. So let's delete these comments. Like we were talking about previously at the beginning for the overview, we want to call start after every awake has been called for each component added on that tick. So to do that, we're going to make a queue here. So let's come up to our class property area, and let's just say this queued for start, and it's going to be a list of components. And we're going to add it to our queue here. So if our component does have start, we are going to this .queued for start .push our component. Okay, cool. So when we do add a component, all this is going to happen, and this is good. So This is important. We don't want to override or overwrite the game object's ID if it's already been given 1. Hence, we checked that the name does not exist first before giving it 1. And then the rest of this, so then we do the queue. Now let's come here to update to finish off our queue for start here. So on the next update that happens, we can do while queued for queue microtask queue for start dot length. If it's greater than 0, that means we have components here, and let's do it from the front. So it's going to be a first in, first out queue. That's how we're using this list. We're going to do component this dot queued for start dot shift. So shift is going to take the first element off the array and give it to us. Now we don't technically have to check for start since we theoretically know we only pushed it here if there was a start, but just to make TypeScript happy, we can just check if's component start component dot start. Bam. And there we go. So we go through our queue, call start and everybody, and then we want to do updates. So quickly, this question mark is the null. I've got a name. I forgot the name of this operator. But what it says is if this is not null, call start. If component is undefined or null, just don't do it. Which is equivalent to if component and component dot start, right? That's the same thing, but it's a shorthand. I can't think of the operator name right now. Okay. So next, we're going to go through all of our game objects and then call the components on each. So let's see here. So because we are a map, so this dot components by game object dot entries, just going to give us the, well, actually, the entries, do we? Let's see. We just do values, which would give us only the components. List. Okay. So const, right, I think it's going to be a list of list, an iterable of list. Let's just do entries. It doesn't really matter. You could make this more efficient by not having to call this and hold your own, although we can assume entries is relatively performant, but I don't actually know that. We may want to look into that. But okay, let's just say we have a bunch of entries here. And then entries dot for, can we do a for of entries? Can I do it? There we go. Entry. So this is the for of loop. So entry is going to be string I component. So we can actually do this. We don't care about the first one, components, which is the list of components. So this is the array destructurings because it is an iterable or an iterator of string component tuple. I think I call it tuple, or just an array of 2 values. So we have a list of components here. So components dot for each, get each component in each game object component dot update, and we're going to want to give it our delta time DTO, right? If probably do this. Actually, I think you can't do this. No. If component dot update, then we want to call update because update is again also optional. Now, more ways to optimize this, of course, is actually you only add it to a list of things to update if there is an update on that component, much like component.start. There's different ways you can optimize this. For simplicity here, we're going to just do it like this. Okay, so we got our update, do our queue for start. Let's do our destroyers. That's easy. So we got to go through all our components again, which is basically this. Just copy this. This is only going to be called one time ever. And what we're going to do is instead of update component.destroy component.destroy. There it goes. That's the cleanup. And the last thing in our component service class here is the find component. We're actually not going to use this in our example, but we're going to build it for you anyway. So what we want to do is find the component of that type on this game object. So first we want to do a list of components, which is easily list.components by game object.get go.name. Now, if not component, so in this case, game object has no components, we can just return, I think, null. Just make sure what the definition here. Oh, it'll just infer it. Also return undefined, just do return type, return null. And then if there is a list here, components.find, and we're going to find for each component.instance of the component type. What do we call this? Component type. Component type. Return. So this is going to return undefined or the component that matches that class type. Right, just like in Unity, you do find component and you get it. Okay, so this is our component service here. Then we just briefly go over it. We did our add component. This game object takes a component based on this iComponent interface. Give it a unique ID. We check that our map has a list of components for it. Then we get that list. We push the new component onto that list. We call the lifecycle hooks with the init. Then we call awake if awake is defined. If start is defined, we add it to our queue for start queue. Then in our first update tick, or in our next update tick, if there is elements in queued for start, we go through it to that queue and call start on all those components in a first in, first out basis by calling shift. And in that same update tick, if we go through all the components and update each one if they have an update method defined. And then for destroy, we do the same thing, go through all our components for each game object and call destroy on all those components if destroy is defined. And then for find component, we get the list of components. If there isn't one, we return null. And if there is a list, then we just find the component in that list that is an instance of the given component type. So that is the component service. Now let's actually use it. Well, I guess first we're going to make an actual component. So let's come here. Now we have this wipe gesture that is for the next video. We're not going to show you that one right now. Let's do a quick click on me component. Doesn't really matter what you call it. Export class click on me component. Component implements. So we want I component, which I component from component service. Let me just, cool. All right, so let's collapse that. So here the problem is that we haven't defined init because that is the one thing that we require. Right, come back here. Everything else is optional. Init is required. So let's go here. Init. Go, and it's going to be a phaser.gameobjects.gameObject, I believe, right? Yep, that's right. Let's just import phaser in here, even though we don't technically need to. Let's just do it. Okay, so that's that. And so in our case, let's just save our, we'll just save this. So private game object, phaser.gameobjects.gameObject. This.gameObject go. You can do some other stuff in it too if you want. It just depends on your component logic. But let's just define awake, and we'll define start just to show you. And let's just say we're going to do console.log awake here. And then we're going to do console.log start. Oops. And this is the click on me components, and we're going to be just real easy here. This dot game object dot on phaser dot events phaser dot type phaser dot So now type phaser dot input dot types, no, dot events dot, yep, here we go. Game object pointer up. And then let's just say we're going to do private handle click. And we're going to do this dot handle click, then context this. And then here, just console.log, clicked on, let's just show you this dot game object dot name. Great. Now let's also implement destroy. And in destroy, we're going to clean up. It'll be all. Okay. So that's our basic component here. What is the complaint? Oh, yes. Let's say we can guarantee this is, we'll just assume init will always get called, so we can do that. Then it makes the code easier to write below it. Okay, so this is our basic component. It's very simple. It does almost nothing other than attach a pointer up listener and then log something. So this is just for simplicity. This is how you make any of your components. So if you wanted to do the swipe gesture, which we'll go into in the next video, we'll put all the logic for swiping in here. And then you can use it for any game object that wants swipe, right? Not just your jellies. If you happen to want swipe on some other item later in your game, some UI, let's say, you can use that same swipe gesture on that UI without having to have your UI somehow inherit from a jelly, because that doesn't make any sense. So this is our component. Very simple. Every component is going to be like this, just with more or less logic in here, roughly. Now let's go to Hello World. So to start using it, we're going to make a component service in each scene. You don't have to necessarily do it this way. Depending on your game, you may want to do it a different way. But we're just going to do one for our scene here. So let's just make private components. Just call it components. And it's going to be of type component service. And let's just adjust this. Good. Components, and let's just say it'll definitely be set, and we're going to do it here. This dot components, new component service. And then, so to call destroy on our components, we're going to do it when the scene shuts down in this case here. So this dot events dot on phaser dot events. No, I don't remember where let me check my notes here. Right, phaser dot scenes dot events dot shutdown. So on the shutdown, we're going to do this dot components dot destroy. Beautiful. Okay, yep, that's right. Good. So that's that. Now we're going to update our components too. So this dot components dot update, pass in delta time so that each of our components can get updated. And then this is, so let's say for each jelly, we do this dot components dot add component, and we're going to say on the jelly, and do a new click on me component, just like that, right? Now we've added a click on me component to this jelly. And let me just make sure yep. Your tilde may not work for you, it just depends on how you set up your project. Okay, so here we've added this component. Now, if we go back to our game here, and a lot of code and whatnot, you see all the awakes get called, then all the starts get called, right? So let me just refresh. There's nine objects here. Refresh. First, all the awakes get called, like we want. Then all the starts get called. Now, of course, this means if I click on one of these, click. Oh, I think my click must be wrong. Okay, let's check here. Phaser.input.events.gameObject pointer up. Oh, sorry. Dot set interactive dot on. I think that's what I missed. Jelly clicked on. So this is the ID. This is the short UUID for this red jelly. So you just remember that that's 5FA, and this guy on the left is 1SH. So click on him again, 5FA, right? So we have this component. It's got this click logic, and for each one, we can do a click. So now we're at about 30 minutes. That's about the end of this video. But you can see you can take this logic. And in fact, if you go to our scene here, if you didn't want to do what I said with, green jellies do something different than yellow jellies, you can, we're doing random here, but let's just say you knew a type of the jelly you were going to do. You can do, like if type equals whatever, blah. You can then this dot add components dot add component jelly like new firebomb components, right? Whatever it may be. It's really up to you, right? For example, just an example. So you can see you can attach components selectively to game objects to give them functionality without having to go through massive, complicated inheritance trees. And so that's it for this video. If you enjoyed this video and you learned something from this component pattern, which I hope you did, do be sure to hit like and subscribe to this channel for more videos on making games on the web with Phaser 3.50 and other web technologies.